So to wrap up this part on linear inequalities, let's talk about some applications. When are we going to see these in word problems? All right. So to serve as president of the United States, you must be at least 35 years old. So there's our key, at least 35 years old. So if I want to write an inequality and graph this solution, my variable is just going to be x. So what is the relationship between x and 35? So to think about this, a president must be at least 35 years old. Okay, so that means that's the minimum that they can be. So x is going to have to be bigger than 35. And now we ask ourselves, does that phrase at least, does that include 35? Could someone that is 35 years old run for president? Yes. Yes, they can. So because they can, then I have to include that equality. They must be at least 35 years old. Another way to say that is they must be bigger, their age must be bigger than or equal to 35. All right, so then if I start with a graph at 35, close circle, shading off to the right. Any age above or equal to 35 can run for president of the United States. Obviously, there are other restrictions according to the Constitution, but we're just talking about that one right now. Okay? Next up, in B, students may have no more than 4 unexcused absences in a year. Okay, so no more than 4. Okay, so what's the relationship between x and 4? Can they have 4 unexcused absences? Yes. They can have no more than 4. They can't have 5, 6, 7, 8, whatever. But they can have 4, so there is equality. All right? And they can have no more than 4. So they have to have stuff that's less than or equal to 4. Okay? So if I wanted to graph this one, okay, if I'm going to start at 4, it's going to be a closed circle at 4. And I'm going to shade to the right, but I want you to think about this in terms of an application problem. All right? What is the least number of absences you can have? Is 0. Okay? So this is going to kind of be stuck between 0 and 4. Okay? So if it was a problem up here and we had x is less than or equal to 4, I wouldn't have to put that restriction on it. But down here, since it's a word problem, the number of unexcused absences is going to be restricted between 0 and 4. All right? And then for this last little section, for Thanksgiving, we will need a turkey weighing above 20 pounds. Write an inequality to graph the solution. So we see here above 20 pounds. So x has to be greater than 20. So I start at 20. Open circle at 20, I shade to the right. Obviously, there's going to be a restriction on this one as well. You're not going to get a 242-pound turkey, okay? But for right now, until we get into our next section, just start thinking about what those restrictions would be, all right? But for now, x is bigger than 20. If you graphed it like this, you'd be all good. But I want you to start thinking about the realistic restrictions that word problems would have, applications would have. Okay? Now let's do a little bit of algebra with this. Let's up the ante. You have $50 to spend at a carnival. Okay, so this is the max. I don't know what happened there. This is the max amount you can spend. All right? It costs $20 for admission and $1.50 for ride tickets. So $20 for admission. This is a one-time fee. $1.50 for ride tickets. This is a recurring fee. I think I may have butchered that spelling. I have to check real quick. No, I got it. Okay, reoccurring. So write an inequality that, oops, I did spell it wrong. There is no O. All right, so write an inequality that describes the possible number of ride tickets you can buy. All right, so if I wanted to write an inequality, let's just think about how much money it's going to cost at the carnival, okay? It's $20 just to get in the door. And then it's $1.50 per ride. So I have to add $1.50 per ride. So X is going to represent the number of rides, okay? And the number of rides I can go on is restricted because I only have $50 to spend. So what is the relationship between the amount of money I'm going to have to spend and my max amount? So $20 and then $1.50 per ride. Well, I can't spend any more than 50. So this is going to have to be less than or equal to 50. All right, so that's how I translate those words into an inequality. So now I want to solve this for x. We're going to solve this just like we normally would. Subtract 20 from both sides. We got 1.5x is less than or equal to 30. Divide both sides by 1.5. And then that will give me 20. So x is less than or equal to 20. So write a sentence that describes your answer with a $50 budget. You can ride at most 20 rides. That's the most you can do. If you ride the 21st, you're not going to have enough money. So since you're restricted by that $50 max amount, you can ride between 0 and 20 rides. Alrighty, let me know if you got any questions.